my name's Sam Taylor, and I'm a watershed scientist. And I'm here to tell you a little bit more about freshwater macroinvertebrates and how they can tell you more about the health in our rivers and streams. Now, the term freshwater macroinvertebrates, it's a little bit of a mouthful, so I want you to just think about these as bugs that live in the river. Now, you may not know it, but in the rivers and streams, really any river and stream you've ever seen, there are lots of bugs in the water. You can't always see them when you're up looking below, because they need to be really good at hiding so they don't become food for fish and other animals. Now, one question you may have already is, why can we learn about the health of our rivers and streams from these bugs? What can bugs really tell us about the world around us? And let me tell you, scientists for many years have had the same questions, and we've learned a lot. There are thousands of different types of bugs, whether it's in the air or in the water or in the trees. And these bugs that live in the river, there's so many types, they like to live in different areas. Some are used to different amounts of pollution. So some are okay living where the water's very cloudy and there's lots of pollution, and some need it to be very, very clean for them to survive. We're going to use these bugs and the bugs that we find here today to tell us a little bit more about the health of our streams. So today, when we're looking at all these different bugs, we can use the macroinvertebrate ID sheet that everyone here has today to tell us a little about which bugs can live in which area and why. Remember, when we're out here looking at these bugs, in our watershed, everything that we put on the ground, unless it's in a sink or a drain like the one in your home, eventually ends up in the rivers and streams around us.
Hi, my name's Hannah Murphy, and I'm a watershed planner scientist. Today we'll be taking samples from our beautiful Millcreek stream. We'll start high in the mountains today and visit 2 other sites downstream. As we move downstream, we'll be leaving snow and mountains and entering more populated and dense areas. As we enter these areas, how do we think the landscape will affect these bugs? Let's find out.
There's a few tools that we have to catch these bugs. Some of the main things we use are a net that's specifically made for catching bugs in the water, and then a bucket that has a screen in the bottom, and another bucket we use to drain. We start, when we're catching these bugs, by cleaning off all the rocks. Because the bugs like to hide on the bottoms so fish can't eat them, we pick up each rock, we clean it off, and it drains downstream into the net that lets water through, but not any of the bugs or particles from the stream. Then, after we've cleaned off the rocks, we use our feet to disturb the sand below. When we do this, it kicks up any bugs that are hiding down in the bottom, and again, they're caught in the net. After we catch all these bugs in the net, we make sure to drain them all right into the bottom, and then we flip it around and drain it into our bucket that has a mesh bottom. This bucket is a little bit like the net, where water can pass through, but all the bugs in the substrate is caught above. After this, we can bring the bucket back to the lab, and we can see all the bugs that we've caught. Here we are at our second sampling site. You'll notice things look a little bit different than when we were up in the mountains. Well, we are still quite close to the mountains, about a mile away from the mouth of the canyon. You'll notice that there are streets, there's a culvert that the stream comes down, and then there are houses bordering the stream. This is pretty common in streams as they move down. Population gets a little bit more dense, and there tends to be more industry. Do you think this has an effect on the bugs that we catch here today? Let's find out. Here we are at our third and final sampling site for today's macroinvertebrate study. You'll notice when we look around that there's freeways nearby, there's a lot more pavement, there's a lot less green space, and in general, it's just a more urban area. We see a lot more industrial usage, and even though there are less houses, there's still a more built and human-made environment and less of a natural environment. Do you think this will have a different effect on the sites than the first and the second sample site we went to? We'll see what the bugs have to show us after this. Now we're back at the lab. We've had a chance to collect 3 samples from different parts of Millcreek. Our first sample was in the upper watershed, our second sample in the middle watershed, and our third sample was in the lower watershed. Now that we've come back to the lab, we've had a chance to take all the bugs out of these samples, and we've counted them and we've identified them. You should all have a copy of your macroinvertebrate identification key, and on the page behind that, you should be able to see the graphs of all these bugs we've counted. It shows the number and the type. Hopefully, together, we can look at this macroinvertebrate key and the number of bugs in each site, and we can figure out what site had the best water quality and why.
In your packets, you should have your macroinvertebrate identification key and, on the next page, graphs that show all the bugs we found and the number of them from each sample site. Take a minute to look at your key and the graphs to decide which sites have the best or worst water quality. Okay, now that we've looked things over, you might have noticed sample site 1 in the upper watershed, we have mostly stoneflies, mayflies, and caddisflies, all of which are in group 1 and are very intolerant of pollution. We do have some black flies and aquatic worms, which are tolerant of pollution, but overall the water quality here seems like it's pretty good. At sample site 2, we have mayflies and caddisflies still, but we've lost all of our stoneflies. There's also a few more of the black flies and aquatic worms. Now, these black flies and aquatic worms don't mean that the water quality is worse, even though they're tolerant of pollution. But I would say that things possibly got worse because we've lost one of our indicator species now that there's no stoneflies. And then at sample site 3, we have no stoneflies or mayflies. We still have caddisflies. We've had the introduction of a lot of scuds, which is like a little shrimp. There's cranefly, clam mussels, planaria, blackfly, and aquatic worms. So now we've lost nearly all of our very intolerant of pollution bugs, except for those caddisflies. We see a lot more animals from group 2, group 3, and even aquatic worms from group 4. It's safe to say sample site 3 in the lower watershed has worse water quality than the 2 above. Between the first 2, both are probably pretty good, but sample site 1 with its stoneflies definitely has the best water quality. Hannah and I want to say thank you so much for your time. I hope you had a great time during the water quality fair. And we hope that moving forward, you'll look under some rocks and rivers and see what these bugs are doing. They're all around you. Don't forget to take a look.